Good morning, dear students. Today we are going to start our section with the topic chemistry of lipids. And in that section, first we need to learn about the biological importance of lipids. Before that, what are lipids? They are heterogeneous group of compounds. That means it is a compound. Lipid is a compound containing heterogeneous group and it is relatively insoluble in water but soluble in non-polar organic solvents. Non-polar organic solvents means such type of solvents, they didn't possess charge difference inside that compounds. There is no negative and positive dipole groups are not present in such type of solvents. Examples are benzene, chloroform, ether, hot alcohol, acetone, etc. So let's see what are the importance of lipids, biological importance of lipids. First, it is a storage form of energy. In what form it is? It acts as a storage form of energy in the form of triglycerides. In the form of triglycerides, what is storing inside our body to meet in emergency situations. Second importance, it is a part of biomembrane. So it is a structural component of biomembranes in the form of what all? Phospholipids and cholesterol. While we learned about the structure of plasma membrane in your lower classes, you have learned about this phospholipids and cholesterol. All these are different forms of lipids. Third importance is that they act as metabolic regulators. How? In the form of certain hormones. Which type of hormones? Steroid hormones and prostaglandins. In the form of these hormones, they can regulate the metabolism. Fourth point, they can access surfactants, detergents, and emulsify agent as they are amphipathic lipids. Amphipathic lipids means they are such compounds having hydrophilic and hydrophobic part. Hydrophilic and hydrophobic regions are there in such type of compounds. So that is amphipathic. And also these lipids can access electric insulators. Electric insulators where in neuron. It has some importance in nerve impulse conduction. And next point is that it provides insulation against changes in external temperature in the form of subcutaneous fat. As there is more subcutaneous fat, then our body will be protected against the extreme external temperature conditions. And also this fat gives shape and contour to the body. That is another importance. And next one, it protects the internal organs. How? By giving a cushioning effect or cushion. It acts as a cushion over the internal organs and protect the internal organs from some external shocks. And also this fat helps in the absorption of fat soluble vitamins, which are fat soluble vitamins A, D, E and K. And this fat improve the taste and palatability of. Okay. Next, we are going to see the classification of lipids. In what way we are classifying lipids? Based on its chemical nature, we are classifying lipids. How? In what way we are classifying? As simple lipids, compound lipids, derived lipids, and finally lipids complex to other compounds or miscellaneous lipids. So let's see what is simple lipids. Simple, it doesn't contain too much constituents. They are esters of what? Esters of fatty acid plus glycerol or some other higher alcohol. So it is a mixture. It is a mixture of what all? Fatty acid plus some alcohol. Normally it will be glycerol or sometimes some other higher alcohol. Then what is this esters? Esters I will show you. Esters are certain uh, organic compound, and it is derived from where? It derived from oxo acid. Oxo acid means oxygen containing acid. And in that acid, what is happening? One hydroxyl group is replaced by an alkoxy group. Then an ester is forming. So here this one is acid, oxo acid. Here the hydroxyl group, it is replaced by an alkoxy group and thereby forming an ester bond, and ester is formed. So ester is an organic compound derived from oxo acid with the replacement of one hydroxyl group with an alkoxy. Clear? So anyway, the simple lipids are esters. Esters of what all? Fatty acids with the glycerol. Next, second category, second classification of lipids is compound lipids. Compound means something also had added along with that symbol. What is added? A third group is coming, and depending on that group, that extra group, they are subclassified as phospholipids that contain phosphoric acid and non-phosphorylated lipids. Clear? So compound lipids means they surely will possess a glycerol or a higher alcohol part will be there, fatty acid part will be there, and along with that a third group will be there. And depending on that third group, what is that third group? Whether it contains phosphoric acid. Then if it contains phosphoric acid, then they are called phospholipids. If in that place, if some other compound present, then they are called non-phosphorylated lipids. Anyway, they are all compound lipids. Okay. This picture is shown here. The picture shown here is that of a phospholipid. So we can see a phosphate group here, glycerol, and two fatty acid chain. So it's a compound lipid. Next, derived from somewhere something has derived. So derived lipids are certain compounds which are derived from lipids or precursors of lipids. It is some compound. Derived lipids are some compounds. They are derived from lipids or precursors of lipids. Examples, fatty acids and sterols. Okay. Then fourth one that we will see in some other section, lipid associated with other substance or miscellaneous lipids. So these are the four classifications of the lipids. Next, we are going to learn about fatty acids. Fatty acids are derived lipids that we have already seen here as examples. So anyway, this fatty acid is the most common component of lipids in the body. In the body, we can see lipids in the form of fatty acids. Then what they are? Basically what they are? We have seen that they are derived lipids. Specifically, they are aliphatic carboxylic acid. Aliphatic carboxylic acid means they are open chain, not in the form of a ring. So aliphatic, and also it possesses a carboxyl group at one end. So we can represent it through a general formula RCOOH. In that COOH, it represents the carboxyl group, and that is the functional group of the fatty acid. And that R represents the hydrocarbon chain, and it will vary from one fatty acid to another. And based on that, the physical properties of fatty acid will vary. So next we are going to see the classification of fatty acid. Fatty acid can be classified in so many different ways. We can see one by one which are those different ways of classification. First, depending on the total number of carbon atoms in that hydrocarbon chain. If the number of carbon atoms in that hydrocarbon chain is even number, then we can call that fatty acid as even chain fatty acid. Clear? The number of carbon atoms in that hydrocarbon chain will be a even number. And most of the naturally occurring lipids possess even chain fatty acids. Then what is odd chain? Odd chain means in that hydrocarbon chain number of carbon atoms be an odd number like 3, 5, 7, etc. And this type of odd chain fatty acids most probably we can see in the microbial cell walls. It's common in microbial cell walls and also it is present in milk. And next type of classification is depending on the length of that hydrocarbon chain. If the length is only of 2 to 6 carbon atom, then that type of fatty acid can be called as short chain. If the length of the that hydrocarbon chain is with 8 to 14 carbon atoms are there, then it can be called as medium chain. If its length or the number of that carbon hydrogen group or the length of that hydrocarbon chain is 16 to 22, that much numbered carbon atoms if present in that hydrocarbon chain, then we can call it as a long chain long chain fatty acid. And if the hydrocarbon chain contain more than 24 carbon atoms, then we can call that fatty acid as very long chain fatty acid based on the number of carbon atoms. Clear? Next, we are going to see another type of classification that is based on the nature of the hydrocarbon chain, whether it possesses a double bond or single bond, like that. So, saturated fatty acids are those fatty acids that doesn't possess a double bond. All bonds are single bond. That type of fatty acids are called saturated fatty acid. Then what is unsaturated fatty acid? Unsaturated fatty acids means it contains a double bonds. Then again they are subclassified to mono unsaturated and polyunsaturated. As the name indicates, this type of fatty acid contains one single double bond. Polyunsaturated means it contains two or more double bonds. That's one type. Then another type of fatty acid is there based on the nature of hydrocarbon chain, that is branch. From that term itself, we could understand that hydrocarbon chain be branched. Then hydroxy fatty acid. Hydroxy fatty acids are those fatty acids in which in that hydrocarbon chain we can locate some hydroxy groups. So these are the different types of classifications of fatty acids. Next, we are going to see about saturated fatty acids. How we can represent this type of fatty acid? It can be represented using the general formula CH3CH2NCOOH. On looking at the general formula, we can understand that depending upon the length of the hydrocarbon chain, the number of CH2 will vary. Its number will vary. Okay, so by that way, we are giving an N here. It can be any number depending upon the length of the hydrocarbon chain. This is the functional group, and this is the other end of the fatty acid chain. Here are some examples of saturated fatty acid. This is the basic simplest type of saturated fatty acid, acetic acid. It's a 2-carbon saturated fatty acid. Butyric acid here means this two CH2 groups are there in between this COOH and CH3. Then coming to palmitic acid, need to notice that the number of CH2 it has increased. It becomes 40. And in the case of stearic acid, again, that means that length of the hydrocarbon chain is more and more. That's why the number of the CH2 it is high in the stearic acid. So, and next is about how, in what way we can name this saturated fatty acid. One way is that by adding a suffix of anoic, anoic, anoic after the what is the status of that hydrocarbon? What is the length of that hydrocarbon chain? One example is given. That's a octanoic acid. That means octane. Octane means 8 be the number of carbon in that hydrocarbon chain. So, and after that anoic, that suffix anoic. So that be octanoic acid. Next, about some special things about this saturated fatty acids. Among them, the 2-carbon acetic acid and the 4-carbon butyric acid. They are important metabolic intermediates in the metabolic pathway. They we can locate them as important intermediates. So next is about palmitic acid and stearic acid. They are the most abundant body fat. Our if we consider our body fat, which are the abundant one, palmitic acid and stearic acid. Then next point is that if we consider different animal species, depending upon that species, the pattern, the composition of fatty acid will vary. If we take the case of human body, a human body's fat, its composition is of 50% oleic acid, 25% palmitic acid, 10% linoleic acid, and 5% stearic acid. Very easily we can memorize that composition using this chord. I'll show you. O plus. Okay. O plus O for oleic acid, P for palmitic, and L for linoleic, and S for stearic acid. As we can memorize these fatty acids in order, then we can very easily remember that concentration gradient sequentially. Okay. So next point is regarding how, in what way we are numbering the fatty acid in the hydrocarbon chain. If we are giving 1, 2 like that, that numbering will start from the COOH onwards. Or else, if we are numbering that carbon using omega, then we are numbering it from the last methyl group onwards in the direction to the COOH. So that's about a numbering of the hydrocarbon chain. Next, we are going to see about unsaturated fatty acid. Unsaturated fatty acid means we know that they are those fatty acids having double bond in its hydrocarbon chain. And in what way we can name those fatty acids, unsaturated fatty acid, by giving the suffix enoic. In the case of saturated fatty acid, we give the suffix anoic. Here, enoic after the systematic name. That is based on the nature of hydrocarbon chain. Then regarding the features, uh, regarding the chemical reaction shown by unsaturated fatty acid, it is same as that of the saturated fatty acids because they both contain the carboxyl group. So with regard to that, both unsaturated and saturated fatty acids show same type of reaction, but some difference exists between them because of the presence of double bond. Okay, and also this unsaturated fatty acid can show geometrical isomerism because double bonds are there and that rotation is restricted only in that double bond, and all the single bonds near to that can undergo spatial rearrangement to give cis and trans form. So we can see this is a cis form and this is the transform. How we can understand that this is cis form and this is transform? Look in the structure. In this structure, the hydrogen attached to the carbon that is bonded with the double bond. It is both hydrogens are on same side. So that's why it's cis. And here that hydrogens are on opposite side. So that's why it's transform. That's about the geometrical isomerism. So unsaturated fatty acids show geometrical isomerism also. It's mentioned here in this box. Then how can we classify this unsaturated fatty acids? They can be classified into mono unsaturated fatty acid and poly unsaturated fatty acid. Then what is mono unsaturated fatty acid? From that name itself, it is clearly explained. Mono, single double bond is there in that unsaturated fatty acid. One double bond. Examples are protonic acid, oleic acid, palmitoleic acid, nervonic acid, etc. So yeah, you have to memorize at least one or two examples for this mono unsaturated fatty acids. Then where commonly where that single bond we can locate. Usually it lie between the ninth and 10th carbon atom in the hydrocarbon chain. So that is the usual position of that single double bond between the ninth and 10th carbon atom. So that position we can designate as delta 9, which indicates the position of the double bond. Then what is polyunsaturated fatty acid? That means more than one double bond we can see in that hydrocarbon chain. Examples, linoleic acid, then elastoic acid, etc. So, we need to remember some examples for this one also. Then on which location we can locate that additional double bond? We have seen that if a single double bond is present, then that will be most probably present between the 9th carbon and the 10th. Then what about that additional? Then that additional bond that will occur between that delta 9th double bond and the methyl terminal end of the hydrocarbon chain. We have seen that, we have learned that in that hydrocarbon chain at one end carboxyl group is there, and in the other end what present? That methyl group. So that additional double bond that will present between the delta 9 the double bond and the terminal methyl group. Then that successive bonds we can represent in this way, and from this indication we can understand that the first bond is between the 9th carbon and the 10th carbon, and the second bond is between the 12th carbon and the 13th carbon, and the third double bond is between the 15th carbon and the 16th carbon. So this is the way how we can represent the position of the double bonds. Then what is the significance of this double bond in unsaturated fatty acids? This double bonds in the fatty acids that give or that reduce the melting point. Here one T is missed. It reduces the melting point of that particular fatty acid. How much it is unsaturated, that will lower its melting point. So that is why most plant fats, they are unsaturated. They contain unsaturated fatty acids like oleic acid and linoleic acid. So that is why most of the plant fats, they exist as liquid at room temperature. While in the case of animal fats, they contain more saturated fatty acids. That's why they are solid at room temperature. So that's the significance of double bond. Then two more terms we need to understand. What are essential fatty acids and what are non-essential fatty acids. Essential fatty acids are those fatty acids that cannot be synthesized by human body. If the human body cannot synthesize, what's the only other option? Need to supplement through the diet. So, for the normal maintenance of the body, through the diet, we need to supplement it. Our food should include such type of fatty acids. So that are essential fatty acids. Examples, 3 polyunsaturated fatty acids are essential fatty acids. Which are they? They are linoleic acid, linolenic acid and arachidonic acid. They are examples of essential fatty acids as well as they are polyunsaturated. Okay, then what about non-essential fatty acids? As essential fatty acid means it cannot be synthesized in the body. Then non-essential means it can synthesize in our body. So don't need to be supplement or not. Don't need to add along your diet. And from where or how the body is synthesizing that non-essential fatty acids? Yeah, the body is synthesizing this non-essential fatty acids from its corresponding saturated fatty acids. How? By introducing a single bond. Examples for non-essential fatty acids are palmitoleic acid and oleic acid. As we have learned about unsaturated fatty acid, it is very important to understand about trans fatty acids. What is this trans fatty acids? They are a particular type of fatty acids produced because of hydrogenation of unsaturated oils. Hydrogenation, reaction of hydrogen with some compound. Hydrogenation is another form of reduction reaction. So hydrogenation of unsaturated oils creates this trans fatty acids, and these trans fatty acids are present in dairy products and also in hydrogenated edible oils. What is the application use of this trans fatty acid, or where all, which all places this trans fatty acids are using? They are especially using in food industry. Why? Because they increase the shelf life of fried food. So, the fast food preparation, that's why everybody are advising to avoid fast food whenever possible. So, the fast food preparations have high TFA content, trans fatty acid. Why they contain more TFA? Because the TFA can increase the shelf life of fried food. And also oils containing PUFA, polyunsaturated fatty acids. They also contain high content of TFA, trans fatty acids. What is the clinical significance of this trans fatty acid? It is injurious for our healthy body, injurious to our health. So it may result in multiple risk factors like an increase in plasma, lipids, lipoproteins, systemic inflammation. Systemic inflammation means what? It is a condition in which our immune system continuously keep on defending our body. Why? Because of prolonged stress, then diseases, and like that, so many factors. And as a result of that, in our body, the level of cytokines and chemokines will increase. And its increase results in its increase stimulate an inflammatory reaction throughout our body. So that is called systemic inflammation. That may also result if our body contain too much TFA, endothelial dysfunction, insulin resistance. All these are conditions that may result out of the presence of trans fatty acids in our body. And also it can increase the risk of cardiovascular disease. Why? How it increases the cardiovascular disease? Because this TFA can increase the ratio of LDL cholesterol to HDL. We know that this LDL cholesterol is the bad cholesterol and HDL is the good cholesterol. So yeah, that TFA increase the ratio of LDL to HDL cholesterol. So that is why in one way it increase the risk of cardiovascular disease. And this TFA is high in all processed foods and bakery products. It's better to avoid all these stuffs whenever possible in our life. And also it is present in partially hydrogenated vegetable oils that are used for. So it's a must that we need to avoid whenever we are purchasing some food items. We need to check whether that contain TFA or not. Okay. So by this we have seen in today's section we have seen the classifications of fatty acid. With this I am going to wind up this section. Thank you.
I'm an icon, man. Ain't my girl about a 10. I should fuck her in the Benz.